Okay, we are back. This is Techmath2. We're looking at chapter 12. We're back in the red book. 12.4, so log formulas. So this is kind of a callback to what we did in the blue book, chapter 15, from the Techmath1 book. So take a look at number 43. And that is on page 531, right on the top. To compare earthquake intensities, the Richter scale, you've heard of the Richter scale, is used according to the formula below. I is the intensity of the earthquake. Little I is the comparison intensity. Find R when I is equal to 10 and big I is equal to 5.3 times 10 to the 7th. Okay. So it's a nice real life example. We are going to have to convert 5.3 times 10 to the 7th. I guess you could just type that into your calculator like that, 5.3 times 10 power 7. I'm just going to convert it and put it in 5, 3, and then add 6 zeros. 1, 2, 3, 4, 5, 6. So 53 million divided by 10. And we're going to just take the log of that. So again, plug and chug into the calculator. You hit log 530000000 divided by 10, end paren, enter. And that'll give you 6.7, which I'm not around earthquakes a lot, but I think that's a great big earthquake, I think. From like watching the news and stuff. If it's 6.7 on the Richter, there was some damage done likely. In an electronic amplifier, power gain N in decibels, input power P sub I, and output power P sub O are related by the formula below. Find N when P sub I is 0.0005 watts and the output is 15 watts. Round to a whole number. Okay, so how many decibels we're finding? And I did have somebody that was into sound engineering take this course, and he did confirm that this was something that he had seen and used before. 0.0005, I mean not with these exact values, I doubt. Divided by, oh wait, the output was supposed to go on the top. I got that backwards. Make sure you put the stuff in the right spots. 15 watt output and 0.0005 watt input. And so times 10, remember, don't forget the times 10. So you type this into your calculator like so. 10 log divided by 0.0005. Just like that, hit enter, round to a whole number, and that's 45 decibels. Okay. Let's take a look at pH 45. So if pH is negative, log H, oops, I forgot to turn on Centrifugio's eyes. Bam! I just changed batteries, so they're pretty bright. So let's look at 45. We have pH is equal to the opposite of log H, and then they tell you H is 1 times 10 to the negative 7. So then again, if we're going to put this in as a decimal, that's 1, 2, 3, 4, 5, a decimal, and then 6 zeros, and then a 1. Now, I know it says -7, but you got to count the 1 as a place. So it went from here, 1, 2, 3, 4, 5, 6, 7. So you only add 6 zeros after the decimal, and then a 1. All right, and so now we just plug and chug again. So pH is equal to the opposite of log, and now just input that number. 2, 3, 4, 5, 6, and 1. And then hit enter. And so that ends up being the acidity of a basic solution reported as pH. Does it say round to a whole number? It says pH is 7. We'll have to pop it in the calculator and double check to see if they round it or what. So negative log of 0.123456 and a 1. Nope, it's 7. You didn't have to round. It's exactly 7. Oh, of course it's exactly 7. 10 to what power would give you to the negative 7? I should have known that. We could have worked it off of that. Oh well. What about if it's 0.0079? So that's pH would equal the opposite of log of 0.0079. And that'll kick out 2.1. Rounded tenths. pH of 2.1. So if you have a pool or a hot tub or something like that, you have to really make sure the pH is on. Otherwise, your skin will be very, very irritated. All right. Let's take a look at 12.5. We'll jump to number 53. 12.5. Number 53. So we got R is equal to log of I over I again. So that's just the same as the one we did before. So we've got R. Oh no, it's different. Okay, good. These are different. I was like, I wonder why I'm doing the exact same problem. It isn't the exact same. This is different. It is 7.8 is equal to the log of the intensity of the little I is 10. And they want me to find the big I. So this is going to require some work. So remember, 10 squared equals 100. Logs are just a fancy way of writing exponents. So log base 10 of 100 is equal to 2. So keeping this in mind, we're going to go from here to there. So what are we going to have? We're going to have, let's rewrite it. So it's log base 10 I over 10 is equal to 7.8. So we have 10 to the 7.8 power is equal to I over 10. And now we're going to cross multiply and solve. So you could do 10 to the 7.8 power. That is a pretty big number. 63095.45 I over 10. And then to cross multiply and solve, it's just going to be times 10. So 630957344.5 is equal to I. And now they want us to round to 2 significant digits. That's a callback, right? Significant digits. So we only get to keep 2 non-zero numbers. So that's going to be 6, 3. And all the rest of these are going to be zeros. So what is that? 630 million. So only 2 significant digits. They did 6.3 times 10 to the 8th. which is really the same thing. They didn't say necessarily write it in scientific notation. So that would be it. Remember how significant digits work. We get these 2, and then none of those zeros count. Now, if there was a 1 or 5 or something, then it captures those zeros. So if we would have put the 9 back in there or rounded to 631, it wouldn't be just 2 significant digits anymore. So that was a bit of a callback. Let's take a look at part B. We've got same thing. I2, I1, and they want us to find, so D, they gave us 35, and they want us to find I sub 2. All right, so same dog, different fleas for this one. Let's take a look. D is equal to 10 log I sub 1, I sub 2. And they want us to find I sub 2 this time. They gave us D is 35 decibels and I sub 1 as 0.0056. They want us to find I sub 2. All right, so we've got some work to do first. Let's divide out that 10. So we have 3.5. Let's write this first. So log base 10, 0.0056 over I sub 2 is equal to 3.5. Now let's write it as an exponent. So 10 to the 3.5 power is equal to 0.0056 over I sub 2. Let's cross multiply and solve. So 10 to the 3.5 power I sub 2 is equal to 0.0056, right? And so now let's take 10 to the 3.5 power. So that is 3,162.27766. I sub 2 is equal to 0.0056. And now let's divide that. 3162.27766. So instead of taking that back into my calculator, I'm just going to do 0.0056 divided by, and then you hit second, and then the negative button on the bottom, and that's answer. And so that'll bring up the last answer that you had in there, so you don't have to type that number again. All right. I did on the work. Ooh, that's a really ugly 2. Sorry about that. All right, and so then enter. That's small. It's 0.0000 1 2 3 4 5 zeros and then 177. And there's more to the number. They probably have it as 1.8. Okay, so they just left it 1.8 times 10 to the negative 7, like that. Oh, sorry, 10 to the negative 6. So either one. They didn't really specify. Oh, wait, they wanted 2 significant digits. So if we were doing the significant digits, that wouldn't be okay. I'd have to go 1, 2, 3, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 zeros, and then a 1 and an 8, and then that would be it. So I couldn't, not this one, because that's 3 significant digits because we have that 7 on there. So we'd have to round it to an 8 and then just 2. These zeros don't count, just the numbers. All right. So a little call back to significant digits there.